We lost our ability to drag and drop when we started using components to represent our tree view items. So let's fix that. Let's take a look at how dragging currently worked in the tree view. So go to your TaskQueue item class, go to tree view item, and we're gonna look for the tree view class. Okay, let's go to treeview.cpp. Right, so let's start looking for some mouse events. Oh, there's one right here, mouse down, mouse up. So what is this tree view content component? Where is it used? Well, a good way to do that is to just look for where its constructor gets called. So right click on it and then find call hierarchy. Oh, so this is what goes inside the viewport, which is inside the tree view. Okay, so let's go back up to the top. Let's go this. So it looks like this mouse down sets some, this is where the whole mouse down selected thing starts to happen. Okay, so look at this comment right here. If the open and close buttons are hidden, we'll treat clicks to the left of the item as a selection click. So let's see. Here we go. It's ignoring clicks to the left of the open. Let's do that thing. And then right down here, if you mouse down inside the body of the item, let's see, item selected true right there. And also select based on modifiers and like item clicked and a couple other. Yeah, okay, so we know that this mouse down is marking an item as selected. So that means there might be a drag or a mouse drag with some guts in it that might help explain how dragging is implemented in this thing so drag and drop works. Let's keep scrolling. Here's a mouse drag right here. And let's see if we can figure out what this is doing. All right, if we're enabled and we're not dragging yet, then we're currently dragging. Okay, and let's see if we found an item at the Y position of where we clicked, because tree view is all about rows of items, so it only, Y position is what matters. Then this line right here, here's where we get the dragged source. If you remember, we had that drag source equals drag demo, that thing right there. That's where we're getting that thing. Right here, and this line says if the item's description isn't an empty var, an instance of the variant class, and the string is not empty, then what does it say next? It says if there's a drag and drop container for this guy. Okay, so we're looking to see if we're inside a drag and drop container class, and if we are, then we make an image. This is the thing that you see when you actually start dragging. And then we call start dragging. Okay, cool. All right, so in our mouse down, we'll select, and in our mouse drag, we will find the drag and drop container and start dragging. Got it. Okay, so we have a way to get drag and drop working again. Let's go and do that. So let's go back to drag and drop. Sorry, let's go back to our TQIC.h right here, and let's add some mouse event handlers. So void mouse down, const mouse event e override. That's one, and we'll do mouse drag. Void mouse drag, const mouse event. Oop, spell that right. Mouse event e override. All right, let's stub out their implementations. Grab this guy, put that there, double colon, that guy there, double colon, get rid of the override keyword, and stubs. Okay, we will start in our mouse down by flipping the selected toggle property. So mouse down, set property, selected, and let's see, no pointer. So we're just gonna flip this guy. So we'll do tree. We want to get that property selected, and we could cast it, but it's easier just to call the conversion operator to make it a bool because it's a variant. So we can just do operator. This guy right here, this is going to convert it to a Boolean. And now we can just invert it. All right, let's run it and see what we get. All right, we got a couple nodes in there, so let's click. Okay, so it's working, but this has the flaw of not deselecting other nodes that are currently selected. Let's see who gets notified when we change selections. Let's go back over to our tqi.cpp, and let's print out the name of the tree that has had a property changed on it. So go down to your property changed callback, right below the repaint. Let's do a debug statement that prints out the name of the tree and the name of ourselves. So that means we need to do this guy right here, tree that changed, so we can have a tree to like check the name on, check that name property. And now we can do debug, and let's do the name of our function, like this, and we'll do tree that changed, and now we will add the name of our tree. So tree that changed name.toString, and close that off, and let's see what our name is. Our name tree name.toString. All right, let's run it and see what happens when we add some nodes, and then when we change that selected property. Give ourselves some more output room here. Okay, it's getting called for that. That's interesting. Let's add one more. Let's clear this. All right, let's click on one of these and see what happens. Okay, so interesting. We clicked on task 1. Task 1 got notified of itself being changed. And also the parent tree got notified that a child was clicked on. So the parent node is going to get notified whenever a child node's property changed. So let's think about how we might deselect that via the parent. So first of all, we are only going to do this for the selected property, so we should filter for that. So let's add our identifier here. And now we can say if identifier equals selected. However, I believe that this is going to be considered a string, so we need to actually force it to be an identifier. Identifier, like that. Yeah, because it could be converted this way or this way, so there would be like an ambiguous, it doesn't know what to turn this into. Okay, so we'll do that first. And then we need to check if the tree that changed is a child, so let's do that next. And tree that changed is a child of us. If it's a child of us, if it's a child of us, then let's iterate through all of our children and set all of them to selected equals false, excluding the tree that changed. So something like that. So for auto child tree, we're going to iterate through all of them. If child does not equal the tree that changed, then child.set property selected false null pointer. So again, if it's the selected property and the tree that changed is a child of our node, then we want to loop through all of the other children on that of ourselves and flip their property, excluding the tree that had changed. Let's try it out and see what happens. All right, let's add some tasks. We got 4 there, and let's click. All right, it's requiring me to click twice. That's weird. And let's see, if I click on task 2, let's see what it does. I turned it off, turned it on. Interesting. Okay, so that kind of worked, but now we have an extra set property call in order to mark a node as selected. This already feels like we're going in the wrong direction, and honestly, one of the things we don't want to do is store the selected state to disk. That's just not something we care about. We don't care about opening a task list from the disk and then remembering which task was selected. So we shouldn't even be storing this information in the value tree. So this is clearly the wrong direction that we want to go. Okay.